You know, we've all heard the promise, right? That AI is going to create a personal tutor for every single student on Earth. It's a revolutionary dream. But what if the very thing that makes these AI tutors so helpful is actually a bug, not a feature? A bug that could stop real learning dead in its tracks. Today, we're going to look at a completely new way to build these tutors, one that swaps out a single, mysterious black box brain for a smart, collaborative team.
So here's our game plan. First, we're going to unpack this paradox that's been holding AI tutors back. Then, we'll meet the Ensemble, this new team of specialized AIs built to fix the problem. We'll check out the conductor that keeps them all working together, look at the pretty dramatic results from their tests, and then finally, we'll explore why this whole team-based approach could be a blueprint for building trustworthy AI pretty much anywhere.
All right, let's dive right into the main problem here. It's a paradox that honestly sounds completely backward, but it's one of the single biggest hurdles for AI in education.
I know, it's a weird question, right? We want AI to be helpful, that's the whole point. But this question gets to the very heart of a major design flaw in a lot of these learning tools. It's this idea that by making things too easy, we might actually be robbing students of the chance to really learn anything.
And that brings us to the mastery gain paradox. See, most big general-purpose AIs, the LLMs, are trained to do one thing above all else: give you a satisfying answer, and fast. They're built for what's called frictionless user satisfaction. But in a classroom setting, that's a total disaster. It completely shortcuts the productive struggle, that key moment of confusion where your brain is actually busy wiring new connections. It prevents real learning from ever happening.
So, if a single all-knowing AI brain is the problem, what's the solution? Well, the researchers behind this idea propose something pretty radical. Instead of one AI genius, what if you had a whole team of specialists, where each one has a very specific job? And here's what that new approach looks like. Don't worry about all the different boxes. The core idea of this Ensemble of Specialized LLMs, or ES-LLMs, is actually really simple. Instead of one big AI black box making all the decisions, you have a conductor, they call it an orchestrator, that directs a whole team of smaller, more focused AIs. It's a total shift from a monologue to a real conversation.
So who's on this dream team? Well, you've got an assessment bot that tracks progress, a scaffold bot to give hints, and even a motivator bot that acts like a cheerleader when things get tough. But arguably the most important player here is the ethics bot. You can think of it as the system's security guard. Its whole job is to enforce the rules, like making sure a student actually tries a problem before they can ask for help.
Okay, so a team of brilliant specialists is great, but they're not much good without a leader who can make them all work together. And that's exactly what the orchestrator does.
And here's the secret sauce. It's a really simple two-step process. In step 1, the team of bots and their conductor use strict, predictable rules to decide what the tutor should do next. This is all pure logic, no guesswork involved. It's only after that decision is locked in that we move to step 2. That's when a single language model is brought in for just one job: figure out the friendliest, most natural way to say what's already been decided. The creative, unpredictable part of the AI never gets to make the actual teaching decision. And that separation, that is everything.
The entire system is built on a really strict hierarchy. Safety and rules always come first. The ethics bot can basically veto any other agent's suggestion. So, if a student asks for a hint without trying, the scaffold bot might suggest giving one, but the ethics bot will just shut it down. This makes the whole system's behavior predictable, transparent, and, most importantly, trustworthy.
Okay, so the theory is solid. But how does this team-based tutor actually perform when you put it in a head-to-head showdown with a standard, single-brained AI? Let's take a look at the results. And the results? Wow. They are just a little different. They're like night and day. Let's take that super important rule, try before you get a hint. The team-based system, with its ethics bot standing guard, enforced it perfectly, 100% of the time. The standard tutor, though, because it's so driven by that built-in need to be helpful, it failed to enforce the rule almost 40% of the time. It was essentially letting students game the system and cheat the learning process.
And it wasn't just about following rules. When actual human education experts were asked to rate the quality of the tutor's guidance, they scored the team-based system at a 4.67 out of 5, and the standard AI, just 2.68. I mean, that is a massive difference in how good they seemed at actually teaching.
And here's a perfect example of why those scores were so different. On the left, you can see the ethics bot jumping in, denying a hint, and telling the student, hey, you gotta try first. But on the right, you see a student who is genuinely struggling. So instead of just repeating itself, the system intelligently shifts gears, offering a totally new analogy about temperature to explain the concept. It's the difference between a simple gatekeeper and a real thoughtful teacher.
So, what was the final verdict? Well, when those human experts looked at conversations from both systems, they preferred the team-based tutor an absolutely overwhelming 91.7% of the time. It really wasn't even a close fight.
So this is obviously a huge breakthrough for AI tutors. But the core idea here, this team-based, rules-first architecture, it has implications that go way, way beyond just the classroom.
The researchers call this the policy generation decoupling paradigm, and it is really the big takeaway of this whole explainer. By separating the strict rule-based decision from the flexible, creative language, you get the best of both worlds. The system's choices become totally transparent and auditable. You can always go back and see exactly which rule led to which action. This could be a blueprint for building safer AI in any high-stakes field. From medical advice bots to financial systems, where making a mistake just isn't an option.
And get this, here's the final twist. You would think that this more complex, safer system would have to be slower and more expensive to run, right? Well, it's the exact opposite. Because that big, powerful language model only has to do one simple job, phrasing. The entire system ended up being 54% cheaper and 22% faster than the standard one-brain model. It's not just better and safer, it's actually more efficient.
And all of this really points to a fundamental question about where AI is headed. We're in this relentless race to build bigger and bigger, more powerful AI brains. But what if we're missing the point? For the kinds of applications that are truly going to shape our lives, maybe the secret to trustworthy AI isn't a bigger brain at all, but simply a better team.